The Golden Retriever Club of America conducted a study of 64 golden retrievers and found the average age at death in a sample to be 11.0 years old. The sample size n is 64 and the average age from this sample is 11, and so x bar equals 11. Let's assume the standard deviation of golden retriever lifespan is known to be 1.2 years, and so this is the standard deviation sigma equals 1.2. Give 3 confidence interval estimates for the unknown mean age at death for golden retrievers, first using 90% confidence, then 95%, and finally 99%. Report your interval in parentheses notation and round your final values to the nearest tenth for simplicity. Be sure to notice the size of the intervals with the different confidence level. Before we answer any question, keep in mind that the goal is to construct the confidence interval for the mean, mu. We do not know the mean, but we are going to construct the confidence interval to estimate the mean. The lower and the upper bound for the interval is computed using the point estimator x bar plus or minus the critical value z times sigma divided by the square root of n. Don't forget to divide by the square root of n here. In this case, x bar is 11. The standard deviation sigma is given 1.2. The sample size n is also given 64. The critical value z depends on the confidence level we use. For the 90% confidence level, the critical value z is 1.645. For the 95% confidence level, the critical value z is almost 2, 1.96 to be precise. And for the 99% confidence level, the critical value z is 2.576. And so all we need to do now is to put everything in this formula to find the lower and the upper bound. For the 90% confidence interval, it is x bar 11 plus or minus z is 1.645 times the standard deviation 1.2 divided by the square root of 64. There are 2 computations here that we would need to do in a calculator. One is 11 minus 1.645 times 1.2 divided by the square root of 64 is 8. And 11 plus 1.645 times 1.2 divided by the square root of 64 again, which is 8. Using a calculator, the lower bound rounded to the nearest tenth is 10.8, and the upper bound rounded to the nearest tenth is 11.2. And so the 90% confidence interval is 10.8, 11.2. For the 95% confidence interval, we would do precisely the same thing, but this time the critical value is 1.96, and so this is 11 plus or minus 1.96 times 1.2 divided by the square root of 64. Everything is the same now except z. Again, there are 2 computations here. One is 11 minus 1.96 times 1.2 divided by 8, and another is 11 plus 1.96 times 1.2 divided by 8. Remember that the square root of 64 is 8. Using a calculator, we just simply type everything in. We do not need to compute each of the term individually because we end up using a calculator anyway. We would get the lower bound of 10.7 and the upper bound of 11.3. With the 95% confidence interval, we will get 10.7, 11.3. For the 99% confidence interval, it is now 11 plus or minus 2.576 times 1.2 divided by the square root of 64. There are two computations again, 11 minus 2.576 times 1.2 divided by 8 and 11 plus 2.576 times 1.2 divided by 8. Input each of these expressions in a calculator. We will obtain the lower bound of 10.6 rounded to one decimal place to the nearest tenth. The upper bound will be 11.4. And so the 99% confidence interval is 10.6 comma 11.4. Now, to compare the sample size for these confidence interval, we need to see how they look like on the number line. On the number line, for example, from 10.5 to 11 to 11.5, we see that for the 90% confidence interval, it is 10.8 to 11.2. And so this is the 95% confidence interval. For the 95% confidence interval, we would go from 10.7, which is less than 10.8, to 11.3, which is more than 11.2. And so the 95% confidence interval is now larger than the 90% confidence interval. And lastly, for the 99% confidence interval, 10.6, which is less than 10.7, and the upper bound is 11.4, which is more than 11.3. And so the 99% confidence interval is wider than the 95% confidence interval. And so we observe that the larger the confidence level, the wider the confidence interval.